Helicopter 9-2 Basic Flight Maneuvers. Ladies and gentlemen, in our continued exploration of helicopter flight dynamics, today we delve into the intricacies of initiating climbs and descents, with a focus on entries and techniques. Now, let's consider the transition into a climb from cruising flight. This discussion presumes familiarity with the normal takeoff from a hover, as we've extensively covered that in a previous section. Now, when initiating a climb while maintaining airspeed, our first actions involve a delicate ballet of controls. Picture this: a simultaneous increase in collective and throttle, accompanied by subtle pedal adjustments to keep that slip-skid indicator right where it belongs. As the collective ascends, a nuanced aft movement of the cyclic is deployed, directing the newfound power into lift while maintaining the airspeed. It's crucial to note that a helicopter can ascend with the nose down and descend with the nose up. Attitude changes primarily signify acceleration or deceleration, not the climb or descent itself. Should our pilot wish to ascend more rapidly with decreased airspeed, a strategic employment of aft cyclic comes into play. Depending on the initial airspeed, this climb can be achieved without boosting the collective, though, as airspeed decreases, a left pedal application becomes necessary due to diminishing airflow over the vertical fin. Now, let's switch gears and discuss leveling off from a climb. As we approach the desired altitude, a careful adjustment of attitude is initiated a few feet prior. The lead in this adjustment depends on the rate of climb, roughly around 10% of the climb rate. Picture this: if climbing at 500 feet per minute, we lead the level off by 50 feet. To commence the level off, a forward cyclic input is applied, adjusting and maintaining a level flight attitude, perhaps slightly nose down. We maintain climb power until the airspeed nears the desired cruising value, followed by a gradual descent of the collective for cruising power, and a dance with the throttle to maintain RPM. Throughout this orchestration, the anti-torque pedals maintain longitudinal trim. Now, onto some common errors to avoid. Failing to juggle proper power and airspeed, holding too much or too little anti-torque pedal, and, in the level off, decreasing power before adjusting the nose to the cruising attitude. Moving on, let's explore the art of the normal descent, a controlled maneuver where the helicopter gracefully loses altitude. To initiate a descent from straight and level flight at cruising airspeed, our pilot lowers the collective to find the sweet spot of power, tweaks the throttle for RPM maintenance, and leans into right anti-torque pedal pressure to keep the heading steady. Picture this: as the airspeed changes, so does the airflow over the vertical stabilizer, demanding a delicate tap dance on the pedals for trim. Remember, the cyclic controls the total lift and thrust vectoring. A certain airspeed requires a specific dance of cyclic and collective movements for level flight. Aft cyclic directs more power to lift, escalating altitude, while forward cyclic channels power to thrust, boosting airspeed. If there's a change only in cyclic without adjusting the collective, the total thrust to lift ratio remains constant, resulting in a dance between climb and descent, mirroring the changes in airspeed. And as we gracefully conclude our descent, imagine leading the desired altitude by around 10% of the rate of descent, adjusting the collective for cruising power, throttling to maintain RPM, and swaying the cyclic to obtain cruising airspeed in that perfect level flight attitude as we reclaim the skies. Now, let's briefly touch upon some common errors to steer clear of. Failing to maintain a constant angle of descent during training, neglecting to level off the aircraft sufficiently leading to a recovery below the desired altitude, and forgetting to adjust anti-torque pedal pressures for changes in power. In this intricate aerial symphony, the pilot, firmly at the controls, meticulously surveys the surrounding airspace, clearing left, right, and above for a safe ascent. External focus is paramount, and communication with the non-controlling pilot remains essential to navigate potential obstacles and anticipate unexpected drifts or altitude changes. Control is an art in this scenario, where the pedals dictate heading, turn direction, and turn rate at the hover. The collective governs hover height, rate of ascent, and descent, while the cyclic exercises authority over helicopter position and travel direction. Once the green light is received, and a clear path is confirmed, the carefully orchestrated ascent commences. Begin with the collective in the down position, the cyclic in a neutral position, or slightly into the wind, and gradually increase the collective. Picture the helicopter becoming delicately light on the skids, with torque and collective increasing, necessitating precise adjustments with the anti-torque pedals to maintain the heading. As the helicopter gracefully departs from the ground, the pilot ensures proper attitude control response and center of gravity. The hover itself is seldom perfectly level, with the aircraft often exhibiting a left-side low orientation due to the counteraction of tail rotor thrust by main rotor tilt. Let's explore some common errors to avoid in this aerial choreography. Failing to ascend vertically during liftoff, pulling excessive collective leading to an undesired gain in altitude, overcontrolling the anti-torque pedals, and reducing throttle abruptly when RPM has been exceeded, resulting in exaggerated heading changes and a descent. Remember, as proficiency grows, the subtlety of pressure, rather than overt control movements, guides the helicopter through this sophisticated performance. Thank you for joining me in unraveling the intricacies of the vertical takeoff to a hover, and until our next discussion, safe and smooth flights to you all.